In this video, we're going to discuss another one of the four conic sections, the ellipse. We're going to talk about how ellipses are defined both geometrically and algebraically, and then we're going to look at some examples. An ellipse is the set of all points in a plane, the sum of whose distances from two fixed points, called the foci, is constant. So the center of an ellipse is the midpoint of the segment between the foci. So if you look at the picture I have over here, is one focus. Here is another focus. Here is the distance between them, and the midpoint of that segment is where the center is going to be located. And then this distance d1 and this distance d2 are going to be added together, and that distance is going to be constant. So if I take my pen and I go all the way around this ellipse, and I'm constantly changing my value of d1 and d2, the sum of d1 and d2 is what's going to remain constant. And note that what we call the major axis of an ellipse is always going to be longer than the minor axis, and we're going to talk about that in a little bit more detail on the following slide. The following is the ellipse with center at the origin and a horizontal major axis. The equation is x squared divided by a squared plus y squared divided by b squared equals 1. The vertices are always going to be located on the major axis, again the major axis being the longer of the two. So here is our major axis. It connects one vertice to the other vertice, and the distance from the center, which in this case is the origin, to the vertices is represented by the letter A. The y-intercepts, also called the covertices, are on what's called the minor axis, and the distance from the center to a covertice is represented by the letter B. So if we look at this, the minor axis, which goes from covertice to covertice, is B plus B, or 2B. So the minor axis equals 2b, and the major axis from the center to each vertice is also an A, so the major axis is going to equal 2a. Then we have the foci located here and here. The distance from the center to the foci is represented by the letter C. And you can find C by this equation. C squared equals A squared minus B squared. Then we have the ellipse, still center at the origin, and a vertical major axis. So this time our vertical runs this way. Here are our vertices from the center to our vertices represented by the letter A. Then we have our minor axis here connecting our two covertices, again from the center to a covertice represented by the letter B. And our foci are now located here and here. So if you can kind of see what's happening between the previous example where the major axis is horizontal and now our major axis is vertical, the foci are always going to be located in the same direction as our vertices. And again, the distance from the center to this foci is represented by the letter C. So the major thing we need to keep in mind with an ellipse, A is always going to be your bigger number. And if you compare this formula, where your major axis is on the horizontal side, you can see how A is underneath your x squared. So that's why you're going to have a major axis being horizontal, because your longer distance is going in the horizontal or the x direction. If we look at this one, here our equation, our A is located underneath our y. So you're going the bigger distance in the y direction, which is going to stretch our ellipse and make it a major axis being vertical instead of horizontal. So now we're going to look at our first example. This is not in standard form. Looking back at our equation always has to equal 1. So in order to get this equation equal to 1, I need to divide this by 36. And whenever I do to one side, I have to do to the other. So now I need to divide both of these by 36. So now I'm going to rewrite my equation in standard form, and I get x squared divided by 9 divided by 36 is 4, plus y squared, 4 divided by 36 is 9. And now that equation is going to equal 1, so now I'm in standard form. The first thing that we need to do is we need to find out where is our center. Well, in this case, I don't have an h and I don't have a k, so my center is at 0, 0. I need to figure out what does a equal. Like I said before, a is always your biggest number. So in this case, 9 is my bigger number. If I take the square root of 9, I get 3. And then I have b. Well, b squared equals 4. So taking the square root of 4, I get 2. So if my center is at 0, 0, my major axis is going to be in the direction of y, because 9 is my bigger number and it's underneath my y. So in the y direction, I need to go 1, 2, 3, 1, 2, 3. And of course, the major axis also gives me my vertices. So now my vertices are at 0, 3 and 0, negative 3. I can go ahead and plot my co-vertices. Again, my co-vertices is the distance from the center. 1, 2. So here's one co-vertice. 1, 2. Here's the other co-vertice. So now I can draw my ellipse. And it says find the foci of the ellipse. So remember, that means I need to figure out what does c equal. Well, c can be found by c squared equals a squared minus b squared. C squared equals a squared, which is 9, minus b squared, which is 4. So c squared equals 5. So now I have that c is going to equal the square root of 5. Again, that distance c is representing the distance from my center to this point C, which is my foci. So now I have my foci are going to be located at 0, square root 5 and 0, negative square root 5. So there we have it. We have found the vertices and the foci of the ellipse and then graphed it. All right, looking at this next example, it says find the equation of the ellipse satisfying the given conditions and then graph it. So in this case, we're given the foci are at negative 6, 0 and 6, 0, and then the length of the major axis is 14. So if you recall, I said the length of the major axis equals 2a. So I can very quickly solve for a and get a equals 7. And again, the foci are found by starting from the center and going out that distance of c. So let's go ahead and graph the information that they've given us. We have the foci is at negative 6, and positive 6, and the length of the major axis is 14. So the length of the major axis tells me I'm going to start at the center and I'm going to go 7 in each direction. But the first thing we need to find is the center. So as we said on the first slide, the center is the midpoint of the two foci. So the midpoint of these two foci, if we traveled 6 and we traveled 6, that makes my center my origin. And then we have A equals 7, so I need to travel a distance of 7 and 7. So there's our major axis. So the one thing that we're missing is B. We can find B by using the equation c squared equals a squared minus b squared. We said that C, again, is the distance from the center to my foci, and that was 6, so we have 6 squared. Then A, again, we found by using that length of the major axis, which is 7, so we have 7 squared minus b squared. So we have 36 equals 49 minus b squared. So then we get b squared equals 49 minus 36, which is 13. So remember, when I have my center at the origin, my equation is x squared, and then we're going to have plus a y squared. And remember that a squared can either be underneath my x or underneath my y, depending upon what direction that major axis is going. Well, if you look at our picture that we have so far, our major axis is in the x direction. Therefore, my A has to go underneath my x, and my b squared has to go underneath my y. So now we have x squared over a squared. So if a is 7, then a squared is 49, plus y squared over b squared, and we just found b squared to be 13. And then don't forget that your equation has to equal 1. So here's the equation for my ellipse. And then in order to graph it, we would have to figure out what b is. So b is going to be the square root of 13. All right, so using our calculator, we can approximate the square root of 13. And we get 3.6. So that's approximately 3.6. So when I come over here to draw my picture, I've got 3.6, 3.6, and I can now draw my ellipse. So that's really a good introduction for ellipses. Keep in mind that that distance A is going to go from your center to your vertice. The distance B is representing the distance from your center to your covertice, and the distance C is from your center to your foci. Keep in mind that A is always going to be your biggest number, and dependent upon whether your A is underneath your X or underneath your Y, is going to tell you if your major axis is horizontal or vertical.